Welcome, Mindsetters, to this grade 12 session of Learn Extra Live. Guys, I hope you're ready, and I hope you guys have got your pens and pads out for this math session. Make sure you're making notes. It's so important, because I've got the lovely Tamlin here who's going to be telling us what we're doing today.
Thanks so much, Ty. This morning we're going to be having a look at paper 2, which is including all your analytical geometry, it's your trigonometry, bit of transformations, bit of statistics. So I hope you're all ready to get stuck into it, and let's get paper 2 sorted out.
All right, awesome.
Thank
so
you.
Tamlin, while you make your way there, I'm going to tell these guys what they have to do. Guys, make sure you get on the page, www.facebook.com/learnextra. Make sure you get chatting to me. Make sure you post your questions if you're lost anyway, if you need help, if you need to slow down, speed up, whatever it is, make sure you get on the page. So also, guys, I have these awesome winter books to give away, so make sure you get posting, and you probably have one of these being sent your way. But for now, I'm going to hand over to Tamlin, who's going to continue with the lesson.
Thank you so much. Thank you. Right, this morning we are going to begin with having a look at analytical geometry, which is generally going to be the first section that you're going to be faced with in your paper. Right, so what we have got is we're going to have a look first of all at question 1, which is this one over here. And let's have a look at what the question says. Right, we have got in the diagram, we have got a triangle where we have got 3 vertices. We've got A, which is the coordinate point of -9 and 12. We've got B, which is the coordinates of 9 and 9. And we've got C, which is the coordinates of -3 and -9, okay? We've got a point in the inside over there, which is point N. The x-coordinate is an A, so we don't know what that is. We've got 7, and sitting down there in this little point over here is our theta. And that is what our question 1 is asking us to do. It's asking us to find the size of theta. Find the size of theta, which is the angle between the y-axis and your line BC. Right. What are we going to do? The first thing you need to remember is that if you are having to find the size of an angle, all right, you are talking about your angle of inclination, okay? And angle of inclination, we've got our tan theta equals the gradient of your line. That is the formula that we need to remember for our inclination, okay? Right, the next thing about inclination is that your angle of inclination is always going to be the angle that is created between the x-axis and the line that we are talking about, okay? So we're talking about line BC. So the first thing we are going to have to do is work out the gradient of line BC. Okay, so let's get going with that. The gradient of line BC is going to be found by taking y1 minus y2 over x1 minus x2. Okay, so let's sub in our values. I'm going to give myself some space here, and let's see what we've got. So therefore we've got y1. Let's call this over here, we're going to call that over there y1, and we're going to call this over here y2. This value we are going to refer to as x1, and this little value over here we are going to refer to as x2. Okay, so let's see, we got y1, which is 9, minus y2, which is -9. So please don't forget to put that in a bracket and put -9 there, over x1. x1 was the value of +9, minus x2, which is the value of -3, and once again, please don't forget to put that in a bracket. Another thing not to please forget is that your y's are always on the top. It is always your change in y over your change in x, okay? Right, what we've got then is I have got 9 plus 9, which is going to give us 18, and I've got 9 plus 3, which is going to give us 12. And if we simplify that, both of them are divided by 6. That is going to give us 3 over 2. It's a positive gradient. Remember grade 12s? If our line is going in this direction over here, that is a positive gradient. And that is the gradient 3 over 2. So now what we need to do is, into our formula, we need to substitute the gradient of 3 over 2. So okay, so we're going to say tan theta is now equal to 3 over 2. What we need to do with our calculators, we're going to take out our calculator, and we are going to press out, and we're going to press Shift, we're going to say tan, and then we've got 3 over 2, close your brackets, equals. Right, so the angle for theta that we have now found is 56. Let's round it off to 1 decimal place. Let's make it 56.3. Okay, so we have now got theta, which is equal to 56.3 degrees. Okay, so let's go back to our diagram and let's just decide exactly where does that 56.3 belong. We said that our angle of inclination is found by going from our x-axis and going up to where the gradient starts. So therefore, this angle over here, 56.3 degrees, is that angle of is that angle over there. Okay, right. We are looking for this angle over here. We know that we've got a 90 degrees sitting at the origin where my x and my y-axis met each other, and we've got 56.3 over there. To find my little angle sitting down there that we need to find the size of, I can do this. I can treat it like a triangle. Now, what we know about a triangle is that the 3 angles of a triangle add up to 180 degrees. Okay, so if that's 90, if that's theta, this angle which we've now found is 56.3. If I do a vertically opposite angles, I can say that this angle inside here is also going to be 56.3 degrees because they are vertically opposite. That gives me a triangle with a 90-degree angle over here, a 56.3 degree angle over there, and my missing angle of theta, which we need to find. So our final calculation to find our theta is going to be this. We are going to say 180 degrees minus the 90 degrees that is at the origin, plus the 56.3 degrees that we found in our previous working out. And that is going to equal the missing angle of theta that we are needing to find. So 180 minus, let's quickly just work out. We've got 90 plus our 56.3. And that is giving us 146.3. Okay, so we've got 146.3 in our brackets. And obviously what we now need to do is take 180 and we need to minus our 146.3. 180 minus our 146.3. And that is leaving us with an angle of 33.7 degrees. Okay, so the angle of theta that we are looking for, the question that asked us, 33 points, and I've now forgotten, 33.7. 33.7 degrees. Okay, so that was finding the angle of theta. So quickly, let's just make sure we all understood that. We had an angle that was sitting not on the x-axis. Okay, that's something that's important to watch out for. If you've got an angle that is not actually on the x-axis, but rather sitting somewhere in the Cartesian plane, okay, and you are having to find the size of that angle, you are going to use your angle of inclination, that's for sure, okay? But when we use our tan theta equals gradient, the angle that that is going to find is the angle from your x-axis to your gradient. Once you have found that angle, you are then going to have to work your way towards the angle that we are actually trying to find, okay? So that could be by means of vertically opposite angles. We could be looking at things like adjacent angles on a straight line. There are various ways that we would be able to get ourselves towards that missing angle of theta that we are obviously having to find. But key thing to remember is that when you're working with your angle of inclination, that formula will find that angle, and obviously that will be your starting point. Okay. Right, so that's now having found our angle. So we've got 33.7. Okay, so let's move on to our next picture. Let's quickly fill in a few things. What we worked out in the previous question was that the gradient from B to C was 3 over 2. I'm just going to fill that in because that might just be useful in this next part. And we've worked out that this angle over here was 33.7 degrees. Okay, so we've got that there just in case we need to work with it. Okay. Right, the next question is now saying we are going to determine the value of A if it is given that our distance from B to N is 5 root 5 units And point A is the coordinates of A, which we don't know, and 7. Okay. Grade 12s, which formula are we working with? Distance formula. Okay, right. So first things first, your distance formula is going to be on your formula sheet, and that's a nice safety net to have, but I would really suggest becoming very familiar with it, that you're able to use it without having to page back and look through your formula sheet. Okay. Okay, so let's have a look. Our distance from B to N is going to be equal to the square root of x1 minus x2. So let's start that one again. Right, x1 minus x2 squared plus y1 minus y2 squared. Okay. Alternatively, if you don't want the big square root on the right-hand side, the other way we can write it is it can be written as bn squared is equal to, now putting a squared on that side basically eliminates the square root on the other side. So therefore what we would be sitting with is just x1 minus x2 squared plus y1 minus y2 squared. Okay, right, what do we know? Okay, let's go back here. We were told that our distance from B to N is 5 root 5. Okay, if we already know the distance from B to N, does everybody agree? That's where it needs to go. It needs to go into the distance from B to N. Okay, so let's fill that in. My distance from B to N, we've been told, is 5 root 5. And be aware that we're going to work with this version of the formula, which means that we are going to square that. Okay, we always like it when we have a surd and a squared because they're always going to cancel each other out. Okay, then we've got x1. Okay, once again, we're going to have to talk about the x1 and x2. So let's call this value over here x1. Let's call this one over here x2. We've got y1. And we've got y2. Okay, just take a moment to do this carefully. It's very easy to get them a little bit muddled, so let's not do any silly things like that. So x1 minus x2 is going to be 9 minus a. 9 minus a, and it is being squared, plus y1 minus y2. y1 is 9 and y2 is 7, so therefore 9 minus 7, and again that is being squared. Okay. Right, what have we got here? 5 root 5 squared. Okay, 5 squared is 25. And then remember that this 5 and the root 5 are being multiplied together. So I've got 5 squared, which is 25, multiplied by the square root of 5 squared, which is going to be just 5. Anything where you've got the square root and it's being squared, what happens is that the square and the square root cancel each other out. Okay. Right, grade 12 is a very common mistake here. Just please watch out for it. If you have got a binomial, 2 terms inside a bracket, and it is being squared, a major no-no is to just go take your squared and go squared, squared. Please watch out, guys. You have to remember to do FOIL with something like that. Right, FOIL, we're going to square the first term. So 9 times 9 is 81. If I do my outers and my inners, I'm going to land up with negative 18a and plus a squared. And at the back here, we've got 9 minus 7, which is 2, and 2 squared is going to be 4. Okay, so we're looking good. Let's just times everything out a little bit more. 25 times by 5, that's going to be 125. We have got an a squared over here. We've got negative 18a. And we've got 81 plus 4, which is going to give us 85. Okay. What we're now going to do is let's bring a over. So I've got 125 over. And we've got a squared minus 18a plus 85. And we're going to have now minus 125. Right, let's quickly just get that. So if we've got 85 minus 125, that's going to give us negative 40. Okay. Okay, so what we've got is a squared minus 18a minus 40. And do you guys agree that what we're sitting with is now a quadratic equation? We're going to solve for a. Okay. We're going to factorize. What we now need to do is we need to find factors of 40 that are going to get us to 18. If we know our times tables fairly well, we can just figure this out quite quickly. If I look at 40, we could break 40 up into 20 times 2, okay? If I take a negative 20 and a plus 2, does everyone agree we're going to get to negative 18? So I've got my a and my a, I've got negative 20, I've got positive 2, and finally when I solve for a, we're going to get an a value of 20 and we're going to get an a value of negative 2. Let's take a quick look at our diagram here. Is it possible that my a value at that point could be positive 20? No. Is it possible that it can be negative 2? Absolutely. So therefore we are going to say that our value for a is negative 2, giving us the coordinates of point N as negative 2, and the y value was positive 7. Right, and that's that question done. We're going to take a short break and we're going to carry on with the rest of that question afterwards.
All right,
Okay.
no problem. So mindsetters, I always tell you, make sure you get on the page, get chatting because it is for you. And guys, make sure you call in on 0861 058 262. Why? Because the first 5 callers get this awesome pack of these winter school books. So make sure you call in. But guys, for now, we're going to see you after this break. Welcome back, Mindsetters. I hope you guys have got your pens and pads out and you guys are making sure you're making notes. But also, guys, I want to send a quick and very big shout out to you guys and Happy Youth Day. Guys, enjoy the day, but also remember the history of South Africa. Make sure you guys go and look it up. Make sure you don't just think of it as just a holiday, it's just a random day. No, it's a very important day, June 16th, Youth Day. Make sure you look it up, very important history. And guys, also, I also want to stress, make sure you call in on 0861 058 262. Make sure you need these winter books, because you know why? We're going to be having boot camp very soon. Don't forget, I know you guys have seen the promos, so make sure you stick around with us during those weeks of July, depending on which grade you're in. But make sure, I know I keep saying it a lot, but I need to stress this very much, that you guys are with us for those boot camps, because it's so important. But for now, I'm actually going to hand back to Tamlin. Tamlin, take it away.
Thank you. Right, let's carry on with this question. What we have now done is we have found the angle of theta, we've managed to find the coordinates of point N, and the next question that they are now asking us is to find the midpoint of line BC. Sure to be there, please make sure you know the formula, definitely a possible question in your paper. Right, so we're looking for the midpoint from point B to point C. Again, the formula, it's on your formula sheet, but make sure you know it, okay? Right, let's see, midpoint, the way we work it out is we take x1, we add x2 and we divide by 2, that's to find the x coordinate. And to find the y coordinate, we take y1 plus y2, and again we divide it by 2. Okay, so let's set ourselves up here quickly. Let's write the coordinates. The coordinate of point B is 9 and 9. The coordinates of point C is -3 and -9. Just as a small tip, grade 9s, when you're doing a question like this, sometimes it helps to just take a moment to do exactly what I've done here. Just write the coordinates down, label which one is x1, which one is x2. It's not going to take you more than 15 seconds to do, and it just helps you get your head straight as to which value belongs in which position, okay? Right, so let's do that. This one over here is going to be our x1 and our y1. We've got our x2 and our y2. Okay, to find our midpoint. Okay, x1, which is 9, plus x2, which is -3, and we are going to divide that by 2, and y1, which is 9, plus y2, which is negative 9, and again we're dividing it by 2. Okay, so let's have a look. We're now going to have 9 minus 3 divided by 2, which is going to be 6 divided by 2, which is going to be 3. And 9 minus 9 is going to end up being 0 divided by 2. And anything where there's nothing divided by 2 is still going to be nothing. So therefore, it's going to be 3 and 0. Right, so let's go back to our diagram. The point 3 and 0, if x is 3 and y is 0, is going to be around about there. It's going to be the x-intercept. So we've got the midpoint of 3 and 0. So what we know is that the distance from there to there is going to be equal to, although it doesn't look completely to scale in this picture, we've proven that they are equal in distance. So therefore, we're proving that that is the midpoint. Okay. Right, and that is that question. Right, last question over here. We are asked to prove that point A, point N, and point M are what we call collinear. All right. Grade 12s, what collinear means is that they're all sitting on the same line, okay? And the way you prove collinear points is you prove that the gradient from the one point to the next point is the same as the gradient from the next point to the next point, okay? So if we can prove that they've got the same gradients, we are proving that they are collinear. They're sitting on the same line, okay? Right, so that is what our mission over here is going to be. We are going to try and prove that the gradient from point A to point N has got to be the same as the gradient from point N to point M, okay? If we can prove they are the same, great, they're collinear. If we can't prove they're the same, then we're proving that they're not collinear, okay? So that's what we've got to try and do. Point A, coordinates of A, let's just quickly write them down again. A was negative 2 and 7. That was proven earlier. Point N is, point A. Sorry, that's point N. Sorry, let's just rewrite that. Point N is a negative 2 and 7. Point N is, where's point N again? Point A is point negative 9 and 12. And point M, which is the one that we've just proven, was 3 and 0. Right, there we go. Okay. Gradients from A to N. Change in y over change in x. So y2 minus y1 over x2 minus x1. Okay. A and N. y2 minus y1, so 12 minus 7, over x2 minus x1, so negative 1 minus negative 2, so negative 9 minus negative 2, and that's going to leave us with 12 minus 7, that's going to leave us with 5, and negative 9 plus 2, that's going to leave us with negative 7, okay? All right, so that's the gradient from A to N. Let's see if we can find the gradient from N to M. Same story, y1 minus y2 over x1 minus x2. Okay, I'm going from N to M. So y1, let's call that one 0, minus y2, which is going to be 7, over x1, which is 3, minus x2, which is negative 2. So 3 minus negative 2. Okay, we've got negative 7, and I've got 3 plus 2, which is going to be 5. What have we got here, grade 12s? I've got one gradient that is negative 5/7, and I've got another gradient which is negative 7 over 5. So unfortunately, have we managed to prove that they are collinear? No, they're not. So basically, this is the story. If we were to draw a line through point A, through point N, and then through point M, there would not be a straight line through those 3 points, because those 3 points do not give us the same gradient. They are not collinear. Okay. Right, so that's the first question. Everybody understanding? I hope everybody is. And let's have a look at the next question. Okay. That were there. Right, okay. What we've got now is our circle diagrams. Okay. We learnt in grade 11 that when we have got a circle where the center is at the origin, our formula for when the center is at the origin is going to be our x squared plus our y squared, which is equal to our r squared, our radius squared. Just to make it interesting, what we do in grade 12 is we take it from the origin and we push it to a different point. So the center of our circle is no longer going to just be at the origin it's now going to move away. Okay? That then lands up giving us a different formula, and we are going to work with that just now. Right, the first thing that they've told us over here is that in the diagram we've got two circles of equal radii. Obviously that's important, so let's just take note of that. We've got equal radii. Okay, and through each point, and point D over there is the coordinates of P and P. The center of the bottom circle is going to be at A, and that lies on the y-axis. This is my y-axis over here. And the other points, and point B lies on the center of the other circle, which is 8 and 7. So let's give ourselves that point over here. Right, 8 and 7. Okay. And the other thing that's been told to us is we've got a tangent. Okay, just to remind you, I'm sure we all remember this from calculus, but your tangent is a straight line that is touching your circle or your other line at just one point. Okay, so this tangent over here is touching both of your circles at your one point. Okay, right, question number 1 they have asked us over here is to determine the coordinates of point D. Okay, the first thing I would notice with point D is that they've got the same letter. The x coordinate they've told me is P, and the y coordinate they've told me is P. So that should be telling you that the x and the y values are going to be the same. Okay, that's quite a nice little hint there. Okay. What we said right in the beginning is that we have got equal radii. Okay? So if there are equal radii, we should then know that the distances are going to be the same, or we could use midpoints. Okay? What we know is we've got this point over here, which is the coordinate of, do we know that? We've got 8 and 7, and it's a common tangent. Do we have all our points over here? Okay, let's have a look. We want point P. It's going to work out to be, we want the equal distance from here to here. So if my distance from, okay, my x coordinate is going to be 8. Okay, so that's sitting over there. So we've managed to move that now. All right, so if that distance over there is 8, this point over here is your midpoint. It's the halfway mark. Okay, which means that on our x-axis, that is going to have to work out to be 4, all right? And this value, we obviously know that the x value and the y value are the same, so as a result, that is also going to work out to be 4, okay? So by using inspection, because we knew that D was the midpoint of these two lines over here, we could work out that our coordinates of D is going to be 4 and 4. Okay. Right, knowing that, so we now know that D is the coordinates of 4 and 4. All right. They have asked us to prove that, hence show that the equation of the circle with center A is given by the formula x squared plus y squared minus 2y minus 24 equals 0. Okay. Right, our formula for the circle center is going to be x minus x1 squared plus y minus y1 squared, and that's equal to our r squared. Okay, remember that this coordinate over here and that coordinate over there are going to form the circle center, the center points of your circle. Okay, so what are we going to do? We are going to have a look at what we've got over here. I know that this point is now sitting on my circumference, okay? And I know that this point over here has got, I do know what the y coordinate is. I know what the x coordinate is. The x coordinate is 0, but we don't know what the y coordinate is, okay? So what do we know? I've got into this x1 and into this x2, we can substitute the naught and the y. We don't know what the y is yet. And what's going to have to be useful over here is we're going to need to work out what that r squared is, the radius. We were told earlier that these two lines were equal in distance. Okay, so if they're equal in distance, I can work out the distance from D to B, and that would then obviously be the same as my radius from A to D. Okay, so let's do that quickly. Let's take our distance from D to B. So dB squared is going to be equal to, let's do our distance formula, x1 minus x2 squared plus y1 minus y2 squared. Okay, our x was 4 and the coordinates of D was 8 and 7. 8 and 7. Okay, so x1 minus x2, let's just do this quickly. 8 minus 4 is going to leave us with 4. That's going to be squared. I've got my y coordinates, which is going to be 7 minus 4, 7, 6 by 4, which is going to be 3. And that is going to be squared. 4 squared is going to be 16. That's going to be 9. I am getting a value of 25, and that is my radius squared. That's my dB squared. Okay, so what I know is that this value over here is therefore going to be 25. Okay, so let's now go ahead and sub into our circle formula. To find the equation of the circle with the center A, we're going to say x minus x1. The circle, the x coordinate of my center, is going to be 0. So we're going to put 0 over here. And that's going to be squared plus we're going to take y minus, okay, let's call it y2 squared, and that's going to be equal to 25. And while I do all of this working out, I'm going to let Ty just chat to you for a minute.
Okay, no problem. So guys, as I've been saying earlier, guys, make sure you get on the page, keep chatting to you, and call in and win a chance to get these books. But guys, also remember, today is a lot of history. Today is June 16th. Make sure you look it up. Make sure you learn about the whole story about Hector Peterson or the entire Sweater Uprising. And make sure you learn about this. But for now, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break. Make sure you went and grabbed whatever you need to, like a snack, water, tea. Make sure you're nice and warm with a blanket so you don't have to go anywhere, so you can pay attention, because this next part is very, very important. So guys, do not move, do not go anywhere. Pay attention. And by the way, I want to say to those guys who've already called in and won, thank you. We've already reached our limit for this lesson's callers. But guys, doesn't mean that you have to now just switch off. Make sure you stay on the page and get chatting, because we're still going to be giving away some of these books to people who've been posting on the page. So guys, make sure you post. But for now, I'm going to hand it straight back to Tamlin.
Thank you, Ty. Right, I hope you've all done a few calculations there and worked it out for me. We had to do a bit of FOIL. We had our x minus 0 squared. We had our y minus 1 squared, which is equal to 25. From there, I took my minus 1 y minus 1 squared. We FOILed it out. We brought our 25 over, and we got to our negative 24. Okay, so that is the first question over there. Let's have a look at one more, I think, analytical question, and then I'm sure everyone's burning to start some trigonometry, so we'll get going with that. Okay, what we've got is we're looking for the equation of the common tangent of FDE. Okay, once again, let's just do ourselves the favor of filling in what we know. We've got 4 and 4. We've got 0 and 1. And right, this is a crucial thing to remember. If we are talking about a tangent to a circle, okay, one key thing to remember is that your radius and your tangent are always going to be at a perpendicular angle, all right? What does that translate into? It means that your gradients are going to be the inverse of each other with the opposite signs, okay? So what we're going to do is we know that the gradient of this line over here is going to be perpendicular to the gradient of that, and I know that because we were told it's a tangent, okay? So what would the gradient from point B to point D be? We know that that's 8 and 7. Right, the gradient from point B to point D is going to be y1 minus y2 over x1 minus x2. I've got 7, I've got 3 over 4. That's our gradient over there. As a result, because I know that this is a tangent, what I'm going to do is I'm then going to say that the gradient from F to E, so my gradient from F to E is then going to be the inverse of that fraction. So therefore what I'm going to do is turn it over. So we're going to make it 4 over 3. And remember, we always change the sign. So if the gradient was positive, we're going to change it to negative, and vice versa. So don't forget that. So that's going to change to negative 4 over 3. Okay? So what we know is this over here is a straight line. So therefore, we've got the equation y equals mx plus c as the equation we need to work with. And straight away, we know what the gradient is, the m. The gradient is going to be negative 4 over 3. Okay, so let's make this look neater. We've got y equals mx plus c. That's going to be the equation of our line FE. And the gradient straight away we know is negative 4 over 3x plus c. All right? As soon as you're trying to find the equation of a line or any graph, what you're looking for is points that are sitting on that line. Any point that is sitting on that line can be substituted into the equation. So if I have got the line and I've got this point D, and point D we worked out right in the beginning was the coordinates of 4 and 4. So let's take the x and the y and let's replace them with 4 and 4. And what we're going to be able to do is solve for c. So we're going to land up with negative 16 over 3. And I'm going to take this over, so we're going to get 4 plus 16 over 3, which is equal to my value for c. If you want to do this quickly on the calculator, it's fine. So we've got 4 plus, we've got 16 over 3. And that is giving us, okay, let's leave it as 28 over 3. Right, 28 over 3, which when we worked it out as a mixed fraction is going to work out to be 3 goes in there 9 times the 3, 9 and a third. Okay. Right, so that's the equation of line FE. We've got y equals, the gradient we said was negative 4 over 3x. And remember, the way we got that is that the gradient of a tangent is always perpendicular to the gradient that is created from the center point of the radius, okay? So your radius and your tangent are always perpendicular. And your y-intercept worked out to be positive 9 and 1/3. All right, okay, that's a little look at analytical geometry. So please remember things like your distance formula, your midpoint formula, angles of inclination, working out the equation of a circle where the center is off the origin. All of those things, if you're just familiar with the formulas, if you're familiar with how to apply the formulas, analytical geometry is actually it's quite a fun section, and often what's nice about it is there's often more than one way to get to an answer. So as long as you are sticking to the rules and you're not sort of veering off it in any funny direction, you will get there, and it's actually quite manageable. You can do it quite easily. I hope the learners think that.
No, they're having fun. Like, please excuse me if I got the name wrong. I'm trying my best.
Yes.
Parthenope says, "Thank you, Tamlin. You're explaining everything so perfectly. I'm enjoying myself." So,
fantastic,
thumbs
great.
up.
Super, wonderful. All right, what I'm going to do is have a look at a little bit of trigonometry. Okay. We had a learner who phoned in and said that they're needing a little bit of extra help with compound angles and double angles. So what I'm going to do is take a moment and let's just explain what those are, where they come from, and how we're going to work with them. Okay. Our identities, let's just quickly take a second. Grade 11 identities. Got to know those like the back of our hands. Grade 11 identities. Right, what is an identity? Okay, we've got two values on the left-hand side and the right-hand side of an equal sign, and basically they look different, okay, but if we were to substitute values into them and actually work out the value of the left-hand side and the value of the right-hand side, they give us exactly the same value, okay. So your identities, they look different essentially, but they have the same values, okay. Right, our first identity, let's work with this one over here. This we should all be pretty familiar with from grade 11. If we've got sine squared theta plus cos squared theta, we all know that it is equal to 1. Okay, right, we remember that. Now, with that identity, we can shuffle them around a little bit and we can actually find other identities. Like, if I were to take cos squared theta to the other side of the equal sign, that's going to give me sine squared theta, which is equal to 1 minus cos squared theta. Right, so that's something to store in the memory there, please. If we ever see a value of 1 minus cos squared theta, we can convert that to sine squared theta, or vice versa, either way, whichever one works for us. The other way of going about it is if I were to leave my cos squared theta on the left-hand side and I were to take the sine squared theta to the right-hand side. That would give us another identity, which is giving us cos squared theta, which is 1 minus sine squared theta. Okay, and the other grade 11 identity, which we all should be well familiar with, is if I've got tan theta, that is the value of sine theta over cos theta. Okay, right, so now what we do is we add our double and our compound angle identities into it. Okay, so let's have a look here. We're going to look at the compound angle formula. Right. I'm not going to prove the compound angle formula because I will be here for the next while and I'm quite sure brains will be boggled at the end. It's quite a complicated proof. Go through it, have a look at it. If I'm not mistaken, they don't ask those proofs in your exams, but it's worth just having a look and seeing what, where it comes from, and it's good to understand the origin of an identity like this. Right, let's have a look. This is what we're going to work with. If I have got cos of A plus B, okay? We're identifying that as a compound angle by the fact that we're working with two different angles inside your bracket, okay? Now, the way that we're going to expand that, what this is going to be equal to is, okay, we are going to have cos A, cos B, minus sine A, sine B. Right. The way I remember it, the way I find an easy way to remember it, is that if we've got a cos compound angle, we're going to group the cos, and we're going to group the sine together. So coses stay together and sines stay together. And a little thing for you to remember is think of C for cos and think of C for change the sign. Okay? So if it was a plus inside the bracket, it is going to become a minus when we expand it. Okay, so there you go. You can remember that if you're in the middle of your exam and you can't remember if the sign changes or not. C for cos, C for change the sign. If I have got cos of A minus B, okay, our identity, the way it's going to expand is we're going to, again, coses are grouped together, so we've got cos A and cos B. C for cos, C for change the sign, so it's now going to change to a plus. And we've got sine A and sine B. Okay, right, so those are your compound angle formula. Right, let's have a look at the double angles. Okay, double angles works like this. This they could ask you in a paper. So watch carefully here, because this is a possible question. They could ask you to say, prove the double angle. Prove that sine of 2 theta is equal to 2 sine theta cos theta. So this here, it's not just good enough to just know it. We actually have to know how we got it, okay? And basically, this is how it works, okay? If I have got sine of 2 theta. Okay, if I were to take that and expand it as a sine double angle, a sine compound angle, which I didn't do. Let's take a second quickly. Let's just finish the sine double angles, compound angles. Sine compound angles, we're going to have sine A cos B. And this time, I want you to think of S for sine and S for stays the same, okay? So that plus is going to stay plus, and then I've got sine A cos B, cos A, sine B. Okay, so that is your sine compound angle, okay? So in this case, the difference between your cos compound angle and your sine compound angle is that your cos is going to be grouped together. We're going to have our cos and our sine grouped together, whereas with our sine compound angle, we now have a mixture, our sine A cos B plus our cos A sine B. And if I had a minus inside here, the only difference is that it would stay a minus over there. Okay, right, so sorry, those are your compound angles, and again, let's quickly talk about double angles. Okay. Okay, so we have sine of 2 theta, which I'm going to expand. I'm going to write that as sine of theta plus theta. Okay, so what I've done is I've just said instead of 2 theta, I've made a compound angle out of it. So because it's now a compound angle, let's expand it like we've just used our compound angle formula. So that's going to be sine A, or sine theta, cos theta, S for sine, S for stays the same, and then I've got cos theta, sine theta. Now you've got to look at these as if they were like terms. If I've got sine theta cos theta plus another sine theta cos theta, then obviously what we're working with is 2 sine theta cos theta. So therefore that is the identity. That's how we actually get it. 2 sine theta cos theta. Okay, so therefore when we have sine of 2 theta, we need to know that the identity for sine of 2 theta is going to be our 2 sine theta cos theta. All right, that's for sine. If I had a cos double angle, cos of 2 theta. Right, grade 12s, this one over here we need to be paying special attention to, and you will see why in a minute. I'm going to expand it as a compound angle, so therefore I've got theta plus theta. Using what we know about compound angles, let's expand it. So I'm going to write it as cos theta, C for cos, C for change the sign, and then sine theta, sine theta. Okay, now if I've got cos theta times cos theta, that is going to be cos squared theta minus sine squared theta. Now the good news is that that is identity number 1. There are 2 more that we need to know. Okay, what we need to now realize is that going back to grade 11 identities, there was another way that we could have written cos squared theta. Okay, we could have written it as 1 minus sine squared theta. So if I took that cos squared theta and I converted it to 1 minus sine squared theta and then continued with the other sine squared theta, when we simplify it, we are going to land up with 1 minus 2 sine squared theta, which is now going to be the second identity that we can work with for the cos double angle. And there's one more. If we go back to the original one, the cos squared theta plus sine squared theta, again, there was an identity for sine squared theta, and that was that it is 1 minus cos squared theta. So let's go and take our first identity, which was cos squared theta, minus, but instead of sine squared theta, I'm going to write it as 1 minus cos squared theta. And when we simplify that, cos squared theta, a negative and a negative are going to make positive. So therefore we're sitting with 2 cos squared theta minus 1. And that, grade 12s, is the third identity that you need to know for cos double angles. Now, what we're going to have to learn how to do is to decide which of the three we're going to apply, which one's going to be the most useful for us to apply and to work with when we're proving identities. And it's pretty easy to see. We're going to prove some identities to actually help you out with that. But I think we're going to take a break, and when we come back, we'll prove a few identities and show you how it all works.
Alrighty. So guys, on that note, make sure you don't go anywhere, because I know you guys have been complaining, no, during the week, an hour is too short. Well, there's still another full 30 minutes of more work to be done. So guys, make sure you stay tuned, and guys, make sure you keep posting on the page. I'm loving it. And by the way, Tamlin, Pindulo wanted to say, thank you so much. I'm enjoying the show. Thumbs up to the teacher. You're rocking. I'm understanding everything. So guys, if you're enjoying yourself, let us know. But for now, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break. And as I said earlier, make sure you have like a cup of tea, something warm, a blanket or something, because winter is cold this year. So make sure you guys are sitting nice, warm, snug in front of your TV and posting on the page. Make sure you get chatting to us on the Facebook page. I'm loving what I'm seeing. Guys, it's awesome to always have you on the page. Keep chatting. And guys, I still have to get rid of these. So make sure the more you chat, the more you frequent on the page, the more you have a chance of getting one of these books sent to you. But for now, I'm actually going to hand over to Tamlin. Tamlin, take it away.
Thank you very much. Right, okay, so we have now had a look at the theory. We've had a look at the identities that we use for compound and for double angles. Now let's put a little bit of theory into practice. Okay, we have got an identity over here. We've got 1 minus cos 2 alpha over sine 2 alpha. And they've asked us to prove that that is all equal to tan alpha. Okay, right, let's go ahead and have a look at what we've got here. The first thing I want you to notice is that over there we have got a cos double angle identity, and down below here we are sitting with a sine double angle identity. Right, so we've got two double angles that we're going to expand, all right? We are trying to prove that it's equal to tan. Now remember, tan can be written as, so let's take tan away, and let's rather write it as sine alpha over cos alpha. Okay. Right, the challenge with a question like this, particularly where we've got a cos double angle, is that we need to use one of three possible identities. Okay, we had a look at the three different ones. We've got to decide which one is going to be the best for me to use. Okay, now the thing is, it doesn't it's not going to be wrong to determine which one you use. It just depends on which one's going to get you to the answer with the least hassle. Okay, so this is my advice. You're going to look at the numerator of your of the left hand side over here, which is 1 minus 2 alpha. And we're going to look at the right-hand side over here, which is the numerator of just sine alpha. So we can see that we are trying to convert all of that to just sine alpha, which to me would say that of the three cos double angle identities, I'm probably going to use the one that just had sine in it, okay? And the one that just had sine in it, let's just write it over here. It was 1 minus 2 sine squared alpha. That was the identity that just had sine in it, okay? So this is what we're going to do. I've got 1 minus, instead of cos 2 alpha, I'm going to fill in here 1 minus 2 sine squared alpha, okay? All right, hope everyone understands what I've done there. So I've chosen that as the identity for my cos double angle. And down below, sine is an easy one because we only have one option, and that is to convert it to 2 sine alpha cos alpha. Okay. Right, what are we sitting with now? Now that I've filled in this bracket, we've got, if I distribute the negative into our bracket, that's going to give us 1 minus 1. That's nice, that cancels out, so 1 minus 1 is gone. And my negative times my negative is now giving me a positive 2 sine squared alpha over 2, and we've got sine alpha cos alpha. Okay, so bearing in mind what we're trying to prove it equal to is sine over cos. Let's not forget that. So we have got now this sine alpha is going to cancel with just one of the signs on the top. Remember, it was sine squared alpha. So that bottom sine alpha has cancelled with one of the tops, and nothing is going to cancel with the cos, so that's got to stay where it is. And my 2's are going to cancel each other out. So what are we left with? I'm left with sine alpha over cos alpha, which once again is equal to tan alpha. And remember, right in the very beginning, that is what we were asked to prove. So we've now managed to prove that all of this, the whole identity of 1 minus cos 2 alpha over sine 2 alpha, is actually equal to tan. Okay, so grade 12, please listen when you are doing an identity like this and you've got that cos double angle. You are going to take a careful look at what you're actually trying to prove, okay? Because if, like we did here, I could see that in this numerator, there was only sine, okay? So it would be very difficult for us to now go and introduce a cos as well, because I don't want that cos there, okay? So as a result, that was why I decided, or we kind of knew, that we were going to use the 1 minus 2 sine squared, okay? The same thing would go for cos. If you were trying to prove something that just had cos in it, then we would be guided towards using the 2 cos squared minus 1 identity, okay? If we're proving a left-hand side equals right-hand side, and the right-hand side had a combination of sines and coses, then we're going to go and use the first one, the cos squared theta minus sine squared theta, okay? Another quick little tip just to bear in mind, if you are doing an identity, and you've kind of hit a little bit of a brick wall, you're not getting anywhere, and you've opened all your identities, you've tried as much as you can try. Just remember this as well. It doesn't apply to this particular question, but I'm just going to mention it, okay? If you ever have a 1, a value of 1, okay, that is actually also a very handy value to have, because don't forget that 1 can convert to sine squared theta plus cos squared theta. So if you're ever in a bit of a stuck position, you've done as much as you can do and you just can't get anywhere, but you've got a 1 sitting in your sum, remember the possibility of being able to actually take that 1 and expand it and change it into sine squared theta plus cos squared theta. You may just find doing that sorts your problem out. Okay, right. Let's have a look at our other trig examples. Got to find them here. Okay, our trig examples are over here. Right. Okay, let's have a look at another example of proving an identity. They're always worthwhile to do because we've always got them in our exams. Okay. Right, we have got sine 3x, and they're asking us to prove that that is equal to 4 sine x times cos squared x minus sine x. Okay. All right, another little tip for you. Lots of tips this morning. If you have got one where there's a left-hand side that's quite short, so you've got quite a little left-hand side, and we've got quite a large right-hand side, okay? Generally, it's going to make your life a lot easier to convert or to expand the shorter side. So don't work with that side over there. Don't try and make that look like sine 3x. It's going to be much easier for you to actually work the other way around and take sine 3x and expand it, okay? So what have we got here? Sine 3x. Now that I could see, if I've got 3x, does everyone agree we could expand that to 1x plus 2x, okay? So what we've done is we've made a compound angle out of it, okay? So with that, we're going to have to use our compound angle formula. And for sine, it's going to look like this. We're going to say sine x cos 2x. Remember, s for sine and s for stays the same. And then I'm going to have cos x and sine 2x. Okay, so we can already see how this little side is not so little anymore. We've managed to expand it already to start looking quite big. All right, so what have we got here? Over here, I can now see I have got a double angle, and again, we're going to have to decide which one of the 3 identities we're going to use. And over here, again, we've got a double angle. That one we don't have to choose. We only have one option. Okay, so let's have a look. at what we're going to do here. I have got cos 2 theta. Now, looking at what I'm trying to prove on the right-hand side, the way I can see it, there's a combination of sines and coses over there. All right? So what I'm going to do is I'm going to use the identity of cos squared theta minus sine squared theta for my cos 2. Or sorry, I'm saying theta, it should be x, okay? All right, so therefore we've got sine x. And in a bracket, please make sure it's in a bracket because it's being multiplied, we have got cos squared x minus sine squared x. I then have got plus cos x. And sine 2x we know is 2 sine x cos x. And again, that's in a bracket because it is being multiplied, okay? Right, let's do a little bit of distribution. Let's take the sine and let's distribute it into the first bracket. That's going to give me sine x and cos squared x, all as one term. If I distribute sine into sine squared x, we're going to land up with negative sine cubed x. And if I distribute my cos into this bracket over here, I have got a 2, and I have got cos squared x, and I've also got a sine x. Okay. What I would also really suggest at this point is take a moment and go back to what they're asking you to prove. Let's just double check what we're actually wanting the number to look like. We are wanting a 4. We're wanting a cos squared x, and then we're wanting sine x at the back over here. Okay, so we're looking for a cos squared x. We want that. Do we have any like terms over here? I've got a sine x cos squared x, and I've got a 2 cos squared x sine x. So in fact, yes, I do have like terms. This one over here and that one over there are like terms. So therefore, what I'm going to do is I'm going to write that as 3 cos squared x sine x minus sine cubed x. Okay. Right, what have we got? We've got a cos squared x, we've got a sine x, we've got a sine cubed x over there, which we probably are going to want to get rid of. Okay, so let's see. I'm going to have to just go underneath here, but that's not a problem. Okay, let's see. We've got 3, we've got cos squared x, sine x, minus sine. Now what I'm going to do is let's convert this, and let's write it as sine squared x. We're trying to get the identity to look with a 4, a sine x cos squared x minus sine x. So we're wanting another. Okay, right. Okay, so we're trying to introduce, we've got 3, we're wanting 4. Okay, so we're needing to try and get another one over here. Having taken the cos cubed x and having split it, okay, so you guys understand, instead of writing it as cos cubed x, I've written it as, sine cubed x, I've written it as sine x times sine squared x, okay? That introduces another identity, okay? And I hope at the moment you know exactly what it is. Think about it for a second. It's 3 cos squared x sine x, and I've got minus sine x. And have you got it? Do you know what the identity is? It's going to be 1 minus cos squared x. Okay, well done. Hope you got that. Okay, and what we're going to do, this is a nice complicated example, we're going to distribute our sine into the bracket. Okay, so 3 cos squared x, sine x is staying as it is for now. We're going to distribute into the bracket, so therefore sine x multiplied by 1 is going to just stay sine x, and negative sine x times by negative cos squared x is going to be positive cos squared x sine x. Okay, right. And look what we've got. We have got another set of like terms, okay? So what we've got is 3 cos squared x sine x plus another 1 cos squared x sine x, which gives us the 4 cos squared x sine x that we were looking for. and minus sine x that we wanted. So yay, we got it that the left-hand side equals the right-hand side, and that's going to be our last statements over there. Our left-hand side is equal to our right-hand side. Okay, right. Lots to think about over there. So what I would really say is go back again and prove that example for yourself again. Okay, go through the steps. It's like a puzzle. You've got to take one step and then you've got to look at another one and see how these pieces fit together. And if you can practice that and learn the skill of identifying which identities you need to substitute into your proof, they're actually quite fun. Geometry, trig, it's all fun. You just got to develop a feel for it, and that feel for it, I'm afraid, is only going to come with lots and lots of practice, which is what you're doing now, so we're all proud of you, but keep at it, okay? All right. Do we have time for another example, or are we going to take
I think we're going to take a little ad break
Okay, we'll
before
give you-
their brains explode, because that is a lot of information.
Okay, perfect.
So mindsetters, yes, please, please, please do not go anywhere, because we'll be right back after this break. See you soon. Welcome back, mindsetters, on this lovely youth day, this Saturday morning. Make sure, guys, you get on the page, keep chatting. And again, guys, on that note,